last topic is solubility. Of course, we all know that like dissolves like. So polar will dissolve polar, non-polar will dissolve non-polar, but polar will not dissolve non-polar. But a common question we come across is how water soluble. Rank the water solubility, okay? So what affects water solubility? If you are non-polar, you will be the least water soluble, right? And that's because, again, water is very polar. And if you are non-polar, you're not going to be very soluble. If you are polar, you will have some water solubility. Okay, so the polarity of the molecule will affect water solubility. And how you be the most water soluble or the best solubility is if you have an H bond acceptor, which means you have a heteroatom in the molecule, an oxygen or an N, okay? But if you have an OH or an NH bond in your molecule then you are the best. You'll be the most water soluble because there you have a hydrogen bond donor and acceptor. It's the same thing. Right, because here the OH can actually integrate with the framework of the water and can participate in hydrogen bonding just as fully as the water. Whereas if we just simply have an oxygen or nitrogen in the molecule, no oxygen, hydrogen, if we just have oxygen or nitrogen in the molecule, we can just coordinate with water. Okay, we can't actually integrate as fully into the hydrogen bonding framework as we can with the formal OH or NH bond. Okay, so here, right, because can hydrogen bond fully, right? Bond fully. Okay, so again, if you have a formal OH or NH bond in your molecule, you'll be the most water soluble by far. Okay, so here we go. Rank in terms of water solubility. Okay, rank in terms of water solubility. So which one's going to be the least soluble? Least soluble. How about this non-polar molecule right in the middle? All we have is carbon and hydrogen. Okay, so non-polar, polar, therefore least soluble. So in terms of what we were just doing, this was 3, right? Because it was least soluble. Okay, how about the most soluble? Well, here the only difference between these other two molecules is their polarity. And they're both going to be across the molecule, yes, okay, in terms of polarity. But as we said before in the last topic, double bonds to heteroatoms are more polar than single bonds. Go back and through and compare the magnetic moments of those examples we went through in class. And it was the double bonds were more polar than the double bonds had greater dipoles than the single bonds. And triple bonds had even greater dipoles, okay, even greater dipoles. So more bonds, again, we have the greater dipole moment, so we are more polar with greater dipole moment. Therefore, most soluble. So this will be 1. Okay, by the way, we're talking about solubility. Just in case you forget the question, okay? So that means this guy is still polar, therefore somewhat soluble. Water soluble. Alright, I only have one more here. Sorry. Okay, so again, the best determining factor is if we can hydrogen bond with water. So here we could definitely accept hydrogen bonds with water with both of these molecules here. But here, do you see this guy? We can fully integrate with the hydrogen bonding of water. Okay, so this guy has H bond, donor, and acceptor. Therefore, H bonding with H2O strongest. Therefore, most soluble. Most soluble. Okay, so that was 3. Sorry, because we were most. Okay. And then in terms, oops, sorry, most soluble up here was 1. Sorry. Most soluble, 1. Okay, so now what about these two? Again, they both have H bond acceptors. They both have oxygens, okay? So they can both coordinate with water, not as fully as the OH bond. But what did we just say in terms of polarity? Right? The dipole of the double bonds are going to be more or stronger than the single bonds. Okay? So I would say here that this guy has a greater dipole, therefore more polar, therefore middle solubility. Whereas this first guy is still polar, but less polar, therefore less water soluble. And again, go back through the notes and look at the magnetic dipole moments. Again, I don't have them off the top of my head, but notice that the doubly bonded double bonds to heteroatoms gave a greater dipole moment than single bonds to heteroatoms. Okay? And again, triple bonds will have even stronger dipole moments, okay? So that will affect your water solubility because of the polarity. Again, what affects water solubility? Pretty much your polarity, as then your ability to H bond. Okay, I think that's it. I think I had a few other questions, what to expect. I gave you guys already practice tests. There's 4 pages of problems. Will you be given a pKa table? No. Is lab material on it? No. Yeah, and if you have any questions at all, just ask.